Are we live? Is it
We
working? I don't know. I'm waiting for the thing over here to start playing. I want to make sure the audio works.
Oh,
I always do this
delay.
on every stream. It's telling me it's waiting for us. I don't think that that's true. There
Refresh.
it goes.
Yeah, it's good on my end.
There it is.
I'm going to reload. I don't see it yet.
I don't think. Sweet.
Oh, I
It
can
is
even
working.
There
So
we
how
go.
are we all doing tonight? Welcome to Joe's Computer Museum. I've got 3 super awesome special guests that I've done some live streams with before. We got Steve of Temporarily Offline. Say hi, Steve.
Hi, Steve. It's great to be here.
We got Matt from Retro Bits.
Hey, everybody. How you doing?
And we got Dr. Dave from Dr. Dave's Diversions.
Good evening.
Hello, everybody, and welcome to the Super Duper stream. So tonight we're going to be primarily talking about reverse engineering of different old 8-bit hardware or whatever bit hardware we like, but that retro computing hardware. And then whatever random stuff we decide that we're going to be talking about if we run out of cool things to chat on. Before we get started, for those who haven't seen me on Steve's stream with these guys before, we're going to go ahead and just give everybody a quick introduction. Steve, say hi to everybody and tell them who you are and what you do.
So I am Steve. Temporarily Offline is my YouTube channel, and I play around with ham radios and vintage electronics. And the last time we streamed together, we did some tech the last time we did the Zork stream. Before that, we did the tech evaluation on the Commodore 64s. Since then, I've got 2 of them repaired. I'll drop links in the chat to the 2 videos. And we were 100% right on one, and we were at least 25% right on the other one. So number 7 was a bad PLA, and number 8 was 8 different chips that were bad.
Sheesh.
So I'll drop some links to that, and we'll see where that goes.
Sweet. Hey, Matt, say hi and tell everybody who you are.
Hey, Joe. I'm Matt. Hi, everybody. Run a channel called Retro Bits on YouTube. We look at a lot of vintage computer stuff, as you would expect. Big-time Commodore fan, so very Commodore-focused. And also, I look at a lot of new products for systems, as well as do things like Mr. FPGA emulation.
Sweet. And Dave, who are you?
Oh, hi, folks. My channel is Dr. Dave's Diversions. It's any kind of diversions I want, but I'm a child of the late 60s and got into computing in the 80s and 90s, so it's heavy and Amiga, Commodore 64 stuff. I'm a Linux systems programmer, and I am also just getting into the Apple II. So I'm like a child at the Apple II, but that's going to be my next video.
We're going to convert you, Dave, I swear. Amiga, come on. No, it's good. I love them all. I have one. It's all good.
Yeah.
So
that's why I'm your friend. I was like, he's got to be all right. He's got an Amiga.
So yeah, we've done some streams before. So tonight we're going to be talking about reverse engineering, the old 8-bit stuff. And I wanted to talk a little bit about the general concept of that process and share some of our collective thoughts and experiences on that with everybody out there so that, you know, if anybody else wants to get into this, they can see it's not that hard. It's really quite simple if you attack it methodically. So the card that I wanted to talk about specifically is this thing right here. This is the Soft Card 3 by Microsoft, and this is the CPM card for the Apple III computer. This was sent to me by viewer Peter Puskarich. I can never pronounce his name correctly. If he's in the chat or in the stream, I apologize. But basically, yeah, he was like, Joe, you want to reverse engineer some stuff? I'm like, okay. But let's talk a little bit about choosing a project to reverse engineer, because that is as important as the actual process itself. You don't want to start out trying to reverse engineer an original IBM PC or anything like that. You want to start small. So that's why I started with this thing.
That doesn't look so small.
Oh, well, you know, it's smaller than some other, you know, more complicated things I'm working on right now, which I can't talk about, but it is pretty straightforward. And the idea here is to pick something that is relatively uncomplicated. in this specific case, the soft card is all Jelly Bean logic. There is nothing super fancy, super complicated. There's no special ASIC chips you got to send off to somebody like Ken Sharif to decap or anything like that, to take pictures of it or anything. It's just basically Jelly Bean logic and a board.
Joe, what does that specifically mean? Jelly bean?
Jelly Bean, generic. It's a term we use. It's been used since the 70s to mean just logic chips, 70 flip flops and 74 series logic,
like off the shelf stuff.
Exactly. Meaning they're cheap as jelly beans. You just buy them by the handful.
Ah, okay.
Yeah. And so since I have a plan to reverse engineer some more complicated stuff, I wanted to start with a card that was desirable enough that when I was done, I could sell some boards, not necessarily try to make a profit on it, but I could sell some boards back to the community and be able to provide something back to the community that's given me so much over the past 5 years or so. But also have something that was, how can I say, not as valuable enough so that if I screw something up, I'm not going to be breaking or destroying a really valuable board, and I'm learning on something a little less, you know what I mean? So that was, that was the general idea there. Thoughts or inputs before I keep yammering on? It just sounds like just me talking here.
You are just talking.
But Joe, can you give us some context? Where is it the first CPM card? Why?
Oh no.
And
so the CPM cards were a big thing for the Apple II, and they were developed by Microsoft, the original Microsoft soft card, the original Z80 soft card for the Apple II, because the Apple was this new platform. But when it came into existence, there was already a very wide set of CPM compatible computers out there, the Osborne, the K Pro, like this thing right back here, that would all run the exact same software. Because CPM was an extremely portable operating system, which DOS is kind of indirectly based off of, but that's another history lesson. So when the Apple II came out, Microsoft created this soft card, and to date, I believe the Apple II soft card is the most sold card for the Apple II, aside from the disk controller and the 80 column card. It was that popular because people wanted to be able to run that huge mass of software on their Apple II and have a kind of like a dual platform.
So I imagine the first Microsoft soft card for the 2 probably came out in 80 or something around there?
I believe it came out in 80 or 79. Yeah.
It would have cost what?
Oh gosh, I think it was like $400 or $500.
Oh my, okay.
Yeah, because basically the idea was you weren't paying for the actual cost of the card, you're paying for the value, which is the same marketing thing that Apple did. The Apple II only cost a couple $100 to make, but they just, they charge $600, $700, $800 and up depending on features because you're paying for value, right? Mm-hmm. That's just typical marketing quackery. Apple's still doing that today with their Apple Watches and their M1 MacBooks and all this other stuff. But anyway, then comes along the Apple III. The Apple III was supposed to be the huge replacement, the huge business computer replacement for the Apple II, and to be the IBM killer. But in order for that compatibility to be there, they're like, well, there are a lot of business applications that run on CPM. Let's make a soft card for the Apple III. And so that's where this comes about. Effectively, the Apple II and Apple III are very similar computers, but not quite the same. Again, another history lesson I'm not going to get into. So the soft card for the Apple III is very similar to the one on the Apple II, but not exactly the same. They have to work out some of those special Apple III quirks. So you can't just like throw an Apple II soft card in there and expect it to work. It's not going to function correctly.
Hey, Joe, is there a Z80 CPU on that card?
There is, and that has to do with the CPM being a Z80 style operating system. It works on the 8080 and the Z80 processors. And so it goes right here, right there, the Z80 processor. And basically, when you engage this card, it takes over the system bus. It becomes its own computer, and then it uses some of that cross compatibility that CPM has, its BIOS as it is, to effectively use the Apple III as a terminal for this. That's what it does.
Right.
So all that said, all that history, these things, people still want these things. I've been reading up on that, and people are like, I want a CPM card. I want a CPM card. And you go on eBay and you can't find them, and they're super expensive and they're hard to find and all this and all that. And I'm like, well, this would be a good first reverse engineering test of a PCB. So that's why I started with that. So the process of doing that is actually pretty easy. The step one is to get some electronics experience first, is building kits, building PCB kits, learning how to desolder stuff from boards on old junk boards and stuff like that, just to get the basics of that. You don't want to go desoldering a really expensive board if it's the first time you've ever done that. And then the next step is going to be finding your target, which we already talked about. I wanted to do the soft card 3. Next, what you want to do is you want to create a bill of materials for what this card is. You want to look at the card and get a list of all of the components as a starting point, and then start taking those components off the board, noting where on the board those components are. And that's just for your own sanity. So when you finally reverse the board and get your parts, you know where to put them back in. I mean, that's no big deal.
So
and then go ahead.
When you're making your bill of materials, do you then start to look at what's available to be purchased?
That is very important. If you're doing this reverse engineering of a board and it's something that's a little weird, it uses a funky timer, a funky counter chip, some weird ROM. For example, this ROM chip right here is kind of hard to find. You'll have to keep a note of that, and then potentially research that chip and see, okay, so what does this chip do? It does this, that, and the other. And then you have to do a little bit of research to say, okay, well, it works in this particular function, but I can get this other chip that does the same thing. And if I reroute the traces in this other certain way, it'll work. It'll do the same thing. It'll just be a different chip. Mm-hmm. Yeah. So those are important. Yeah.
So the thing that, so you started with the premise of, could you build exactly the same thing?
Exactly.
Maybe you're going to get into that, but right away you can also go, do I need to build the same thing or not? What is there an advantage to doing it the same way, just so you are guaranteed it's going to work? Or when you start saying, well, over 30 years, this subsystem and it doesn't even make sense anymore.
Sure. The combination of both. So for me, since I'm starting out and this is my first big project, I'm trying to do a 1-to-1 clone of this board, so that I get a really good understanding how it's laid out, interconnected, and functions. Because somebody else has already designed this board and it already flipping works. I'm not going to reinvent the wheel yet.
Yeah.
Yet.
And diagnosing yours would be awesome then, right? Because you can go to point by point and put probes right there and say, is it doing the same thing?
Exactly. And then after that, then you can start to refine the design. For example, this is all through-hole design, right? Which makes it super easy to throw together, solder, make, do whatever. After that, though, you can look through and say, okay, do I want to convert this to be surface mount chips? Do I want to change this ROM chip to a different kind that's easier to find? Do I want to go with a 40 or a quad flat pack Z80? What can I do to speed it up by increasing the clock speed? There are lots of different things you can then start to go through once you have it reversed and well understood. You could skip that step if you've already done some of these before, and by using the schematic, redesign based off the schematic, then draw a completely new board. But I've found that, at least in the case of the soft card 3, I've searched 3 or 4 times. There are no schematics I can find for this board. So I'd have to redraw the schematic myself anyway, which I might as well do while I'm doing this process and whatnot.
Since you mentioned it anyway, just because a product's not available for sale doesn't mean someone hasn't reverse engineered it in the past.
Correct.
Is there a collected body of knowledge where reverse engineered things, sort of like an internet archive of hardware? Does something like that exist?
That's a very good question. I don't know the answer to that. Google.com. I don't know.
So can I throw something in there?
Sure.
Matt. So in my project, I started to do that I'll be talking about. I started to do what Joe was doing and said, I know exactly I want this thing that I already own. I want to duplicate it. But then one of the steps that you can do is research in the community. Has anyone done this before? And lo and behold, I found almost 30 years ago someone did it before. And it was a little bit of a deep dive to get the stuff, because it wasn't on the Internet Archive. It was in IFF format, Amiga images, only on Ambinet. So what I loved about it, I know my inclination as a research scientist is you have to know the related work before anyone cares about what you did. And I'm not saying everyone should do it that way, but the super cool thing was we took two prongs and started developing. And also in parallel, I was researching it and said, oh my God, we found another one that's easier to duplicate that no one seems to have talked about for 25 years. So the Matt's point is, I think, well taken, that go find out, or if you're not connecting with the community, go find the archives and see, did anyone else ever talk about this? Did another company that's defunct now ever make such a thing? Because that's the other thing I discovered. And that was really exciting because it gave us options. Wow,
that is a good point. During this process, I did find out somebody has already completely reverse engineered this exact board. So, that's a thing. But
it's still worthwhile to reverse engineer it on your own. You're in the learning, you're in the beginning of the hockey curve.
Exactly.
And so you're getting a lot of value out of doing that. And it's hard to think about it in those terms, because you're like, well, somebody already did this, I can't do this. But at the end of the day, you will gain so much adjacent knowledge by doing this that you might already have, you might not have. But I know I don't already have this knowledge. So I would be able to pick up a lot just by pure cloning. Have you found schematics for this online anywhere, or looked?
I have looked several times. I have not been able to find schematics for the Soft Card 3. No, I even double checked just before the stream just to make sure, and I still didn't find any. There are plenty for the Soft Card 2 and its different versions for the Apple II, but I'm guessing that the schematics for the 3 have been just lost to time, mostly because the Apple III was one of those. They only sold 100,000 of them and then they disappeared. So it's just one of those. It's rare enough that nobody cares type of thing. But on the flip side of that, the Apple III owners out there love their Apple IIIs to death, and they want an option. So, and to touch on that as well, talking about, it's already been done. Why are you doing it? To learn. Exactly. I want to learn this process with a card that is uncomplicated, straightforward, easy enough to copy, to learn a lot of the processes. What software do we use? How do we get a copy of the footprint into the computer? How do we lay it out? How do we figure out what chips to use? All of these processes it's easier to use an existing board and learn on something that is a unknown, so to speak. So you can compare, like Dave was saying, so you can compare something that works with something that you're redesigning to see if you get there. From there, you can iterate on it. And do different versions of that. Then you can start to escalate into more complicated things. Well, I know how to dump ROMs now. I have resources in the industry or in the community that I know will help me decap or dump this weird chip on this other more complicated device later. Building those resources out. So that's kind of why I wanted to start there. So, so I guess the next step is. So we've got our target. We know what we want to do. We depopulated the board. We need to get this board into the computer so that we can copy it, so we can rewrite the traces. And basically, you just use a flatbed scanner. If it'll fit on the flatbed scanner, you scan it in. And then I'll see if I can pop it up on a second screen here, because I have this.
I tried to do that with my project, the flatbed scanner, and I couldn't get it to focus. So I ended up having better luck with my phone. Is there some trick to getting a flatbed scanner to focus at the right, if it won't lay completely flat?
That's a very good question. I'm not sure. I was able to completely depopulate my board, and then I went over it with my hand here. I just rubbed it just to make sure there was nothing, so it's not going to teeter-totter. Yep. And then I was able to scan it really easily. I think that's going to be your primary thing, is to get that board as flat as you possibly can.
Yeah, mine was focusing on the top of the chip, so I could read what the chip was, but once you got to the traces, it was blurry. So the phone worked really well.
Yeah, you can use a phone. The trick with the phone is that it can have some issues with one-to-one layout. Because the phone, because it uses a lens, it's going to be distorted at the edges and things like that. So there can be issues. So the consensus is to use a flatbed scanner because it's directly parallel.
Makes sense.
Perpendicular, I mean. But yeah, so you scan that in. You have to know your DPI of how you're scanning it in, and then you can use.
Joe, can you make that big?
Yes, I can.
Thank you.
There you go. Is that better, everybody?
Yeah, that's nice.
Look at that.
So basically, this is Sprint Layout 6. It is a $50 program. If you're going to be doing reverse engineering, I highly suggest you just go ahead and purchase a copy of this program because KiCad, I did research for at least a couple days to try to figure out how to do this with KiCad. It failed. It's maybe possible. I don't know. But Sprint Layout makes this insanely easy. It's like it's designed for it. I heard somebody was about to have a question.
I was, yeah. So you say Sprint Layout.
Mm-hmm.
Is that what drew the blue lines all over everything?
Exactly. That is exactly what it is. So you can change which side of the board you're looking at and all of that stuff. And so what you do is you create a layout, you save it somewhere, all that. But what you do is you can go in here, go into the scan copy option and load a bitmap. And once you load that, it shows that bitmap in here. As part of that process too, you can tell it the resolution of your bitmap. So once you've done that, it will bring it in 1-to-1 accurate to the physical actual size. So there's no guessing. Is it laid out right? Is it straight? Whatever, blah, 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 blah. You may need to use an image manipulation program like, Photoshop. I'm old. I use Jask Paint Shop Pro from 1990. But whatever. You want to make sure you
Love
get it.
Paint Shop Pro.
I know, it's great. It's cheap and it works. You get it. You need to make sure you get nice straight right angles on all your corners and all of that stuff, because if your board is askew any like that, it can Paint Shop Pro 7, baby.
No one can see it but you, Joe.
Yeah. Here. Show everybody Paint Shop Pro. Yes.
Man, that brings
I
back
have
memories
that.
of the 90s.
Yeah, I've been a Paint Shop Pro fan since version 3.
Oh man, I used to use that, but I've been
Just enough.
Yeah.
using it for many years now. Can't go back.
There, let's do that. That way everybody can see you.
So Joe, in your scan there, the
Yeah.
heavy traces that aren't marked in blue, is that
Yes.
a mistake in it, or is it discriminating between the fine traces and the heavy ones?
No, I haven't finished it yet.
I see.
I haven't done,
But I
yeah,
thought so it wasn't automatic, the blue part, or was?
No.
Okay.
No. So for example, here's the back of the board and there's nothing on it. I just haven't finished tracing it yet.
I see.
So back to that. Yeah, so you get them in 1-to-1, and you also have to make sure you're scanning both sides of the board. Right? That's important. And there might be other image manipulation tricks you'll have to do when you scan the board in to make sure that they're the same size and all of that stuff. Frank's 3 Shop is saying in the comments here, from a scanner, the image would make it more square, and that's absolutely true. You might be able to tell right here at the top of the image, though. You might see a little bit of a ruler I shoved in there as a spacer, because my scanner tends to crop off the top of stuff. So you have to pay attention to that. It also helped me keep it square to the top of the scan bed, but details. Anyway, once you get both of those in, then you can start laying out paths. So you can do things like click a pad and put individual pads and locations.
Nice.
And you can define the pad size, its outside dimension, its inner dimension, all of that stuff. And you can start doing traces, which am I on the right side? So like if I wanted to do a trace here, I can just draw the trace like that and just connect the different points. Of course, this is a thick trace, so we want that to be like a 1 millimeter trace probably. Yeah. So there's a 1 millimeter trace, and then it's traced and done. And you just repeat that for the entire board. You're just drawing over top of what is already there.
So you're trying very specifically to get this to be like size and layout and footprint correct?
Yes, mainly because it's just easy. I don't have to think about it. I'm not like, well, what connects to what? I can see it. I just draw over top of it and make sure that traces aren't connecting where the traces and pads aren't connecting where they shouldn't be connected. That's basically all you do. And you can do other things, like here's this text that's right there, the soft card name, and you can use the silkscreen layer here to lay down text that goes in specific locations. I don't know where that went to. It disappeared on the board somewhere. I'll find it during QA. But yeah, so you can use these different layers, C1 being the top layer, S1 the top, the trace layer, what's the name of that element? Copper, grain, geez. S1 being silkscreen, being the letters on the top, which are in red here. The C2 layer being the back. And of course, this is intelligent. When I switch to select the back C2 layer down here in the lower left of my screen, you might not be able to see that. Then my name might be over top of it. Yeah, it's hard to say. But when you select the layer, then it automatically flips to the image you've set it to be that back layer. And then you can just draw over these. So, okay, I want this trace to go here. It goes here and here, like this, da, 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 da. And then, see, it's kind of cattywampus. It's not exact. So you can come in and redefine these draw points to get them a little more exact. And you just keep refining that as you go. Yep, and there you go. There's a trace. That's the trace on the backside done. And you just repeat that 42,000 times over the course of 5 days. And then you've got a reverse engineered board. It's really straightforward.
Joe, in this one, I'm imagining from the era that these were hand-drawn traces.
Oh, yeah.
So what's where's the decision, or how do you make the decision between that and describing the connections to software and having it routed automatically? Because you'd still be making the same circuit, but it might come out smaller or in a different, different layout.
Again, in this specific case, because we're coming not from a schematic that's been imported into a router, because we're just drawing it. Back in the day when these were designed, they didn't have computer-aided tools, so they literally drew it out on paper. They drew it on grid paper with sometimes
like lithography, right?
Basically. They would when they were doing chips, they would use Ruby Lith. They use these gigantic, huge sheets of like cut out transparencies. But this was basically the same thing. They were literally taping it off with pieces of masking tape, manually following a sheet of to their side, a sheet of the schematics. And that's why a lot of these too on this board, they're all like wavy and curvy and all sexy and suave. Right. It's because somebody drew it with masking
because it's artistic, and you can see that right away when you look at a board from the 70s or earlier, right? Exactly.
So these modern boards use all these nice right angles. They're using nice hard edges and stuff like that. And that's because they're computer routed. They routed on, 45 degrees everywhere to do the thing. And that is an option too. If you're designing a board from scratch, obviously you can, with KiCad can do this, I believe. You can give it your schematic file that you've drawn, and it will auto route the whole thing. And then you can literally drag your footprints around and then physically lay it out and clean up the traces.
But you hear the work that you've done. You've also made an inventory of the connections, right?
Exactly. In theory, there is, a way to export that information. I haven't gotten that far in my intelligence gathering process, so I'm not sure how to do that. But I would think that Sprint Layout could probably do that, which you could then use to import into another tool and do another layout, maybe? I don't know. Not sure.
As a completely naive about this, for the kind of cards, say, like, for instance, in 8-bit computers, do we ever have to worry about the length of the traces participating in the circuit?
I would say under most circumstances you would not, because these things usually aren't running faster than maybe like 15 megahertz. You're not worried too much about crosstalk, and usually, as you can see in this area, all these chips have good quality decoupling capacitors, and with all these thick traces, you can tell that your power and grounds are nice thick traces to reduce inductance on the lines. But yes, as you start to get to higher frequency stuff, you absolutely have to worry about that. Higher frequency parallel buses can be a real problem if the length of those bus lines varies along the line, because then you could have certain bits coming in before other bits have come in, because that timing is so tight. When you start to get that fast, you're getting down to nanosecond levels, and your trace lengths the signal running along the trace length could take a half nanosecond longer if it's a half-inch longer.
Right. That's a good point about the timing part. And I think like people like Steve and I that are radio amateurs, the other thing we think about is what can there be a length where it would resonate, and it ends up being a receiver or a transmitter of a radio signal that has nothing to do with the device itself.
This is true, and that's why we have FCC Part 15 and all of that stuff as well. But in this particular case, in the 80s, they didn't care. They just swapped stuff together. And that's why in the Apple III specifically, that's why the Apple III is one big, like 45-pound hunk of aluminum, was just to reduce radio emissions.
Or think of the Atari 400 and 800 that also came out before the VIC, for instance, the VIC 20, and it's built like a tank because the FCC restrictions were different than they were in the early 80s.
You can see that in monitor evolution too. As you take apart older monitors, there's way more RF shielding. Then it goes away entirely by the time you get to the 90s.
True.
So I want to say that Bill Hurd said that the Commodore 64 RF shield was for the 160 meter band. So somewhere in the 1.7 to 2.0 kilohertz range. So I want to play with that. Turn it on without the shield on, tune in, see if I can hear something.
Put a straight key on your 64 and see if you can see.
Yep. That's coming up though. I'm going to be doing that soon anyway.
Good idea.
Yes. I have a couple of questions in the chat here. Someone said, Rudy is saying, manually drawn is a deadly art. Fun for simple board work, but more complex work will make you lose your hair. Yes. Yes, the tinier those traces get, the larger, more complex the board will get, especially when you're talking about 3-layer boards, 6-layer boards, all of that. No, that's a lesson in insanity. And is a completely different animal that I haven't gotten into yet. Hubris Inc. is saying, what's the process for reverse engineering a multi-layer board? I assume this graphical technique doesn't do much for internal traces. Correct. So multi-layer, what you would want to use in that case is a little bit more complex tool probably than Sprint Layout. Sprint Layout can do a maximum of 4 layers. And if you're doing anything more than that, then you start having, it can't do it. But those internal layers, you can't see them. Right, you can do the front and back, but you don't know what those internal layers are. They might just be grounded power planes, but they might actually have data paths on them. So in those cases, you need to either use some really, really fancy X-ray stuff that only high-end physics lab have access to, or what a lot of people do is they will actually take the board and put it on a flat sander and sand the board down until they get to a layer. Photograph that, sand it again, photograph that, and use that to reverse engineer it. There's a project to reverse engineer the SE30 board, which is exactly what they did. It's a multi-layer board. It's got a few traces on some internal layers, and they literally took an already dead board and just sanded it down until they found those internal layers. So that's how you would do that. RetroTech Chris is saying, people used to generate music from the TRS-80 by generating RF interference patterns. Yes, that was a thing. There used to be instructions where they're like, put your AM radio next to your computer to hear the music.
People that didn't have a SID, those other computers, they're like, how are we going to do this?
Like,
Get creative.
Those TRS-80 guys.
So Joe,
yes.
In a project of this scope, what are the common pitfalls? What could go wrong?
Oh, lots of different things. So if you're reverse engineering a board like this that already has trace damage, you could miss trace connections. That's a thing. And so you could design this, looks perfect, spin the board, get some boards in, solder it, and it doesn't freaking work, and you think you did something wrong when really the board was already bad. There could obviously you could just miss a trace. There could be an error in your process. Right. So before you send it off to have some boards cooked, you want to go over it with a fine-tooth comb, almost like grit it out mentally and check everything to make sure your layout is good, obviously. The other thing is, so what if you're reverse engineering a board that is sold that there's a chip that you can't get? You're going to have to then find a suitable replacement by finding, your data sheet for the original chip, figuring out exactly what it is, doing your darndest to determine timing requirements and all that stuff, how fast or slow it needs to be, setup times, propagation delay, all that other nerdy starts to get into quantum physics crap, and then finding that a replacement chip to do that. For example, this board I believe has it has a counter on it somewhere. I think these 113s up here, these 74 LS 113s are counters that are a little bit hard to get. And you could replace it with like a 74 HC 4040 or something like that. That's a much more complex counter chip, but you would just wire it differently and ignore some of those other counter pins. But it's a factor of what do I need to replace it with to make this thing happen, right? Another thing in this case, again, is this chip, the ROM chip right here. This is a 256 byte ROM chip. Good luck finding a chip these days that has 256 bytes on it. The other team who already reverse engineered this was able to find a replacement chip. I did a quick search and couldn't find squat.
Aren't there other 256 byte ROM chips in the Apple anyway? Wasn't that Wozniak's disk drive thing?
Yes, the Disk 2 controller has 256 byte ROMs on them as well. It has two of them. One is the state machine that determines the bit patterns laid out on the disk, and the other one is the actual code that runs the controller, I think, or something like that.
Cool.
So but yeah, those are the complications, that I have come across so far. But there could be others that I don't know about. Again, because I'm just baby reverse engineer here. So,
Joe, did you come to so you've gotten to the bill of materials phase? What are the costs? Like, was that a factor at all in you deciding what you were going to reproduce or not?
Not really. The costs on these are. This is the reason why they call it jelly bean logic for the most part, because they're frigging cheap, especially if
tens of cents or something.
Well, yes, for the surface mount components, if you're going to be buying them in quantities of 100 or more, they're super cheap. The processors of the Z80 is a little expensive. That's about $5 or $6 a piece. But when you think about the entire project, it's really not a big thing. Like if you were to reverse engineer the Apple II or the Apple III, for example, that'd be a whole other ball of wax. That'd be several $100s. And as a matter of fact, people have already done that. And yeah, bare boards are selling for like $200 and $300 because that's just how much they cost in engineering time, plus the time it takes, or the cost it takes to spin, a 16 by 20 inch board, right? They're huge. But little boards like this, a board of this physical size like that, I mean, it's not that large. It's like the size of my head. This board here in bulk would probably cost $3 or $4 for the board.
And the card edges, do those have a fixed cost what you're inserting into, or is that
typically? Yeah, the card edges, typically you'll get charged an extra flat fee per board to have those, because they have to go through a special process to coat them the way you want to coat them. You can get them just solder coated if you just tinned, which is usually fine. But if you want them gold coated, there's a little bit extra because gold, and they have to go through special processes to do the unmasking of that section and all of that stuff. But it's usually not a lot of extra cost. It's usually a flat cost per board. And then, you got your cost of your chips, which we already talked about. The cost of like your resistors and stuff. You buy them in quantities of 1,000. They're all standard sizes. If you're a nerd like me, you're doing projects and junk all the time anyway. So it's no big deal to just buy 1,000. And then they cost hundredths of a cent a piece. It's like, who cares, right? The other factor that can affect cost is going to be how you want to populate the board. For example, if you want to populate the board with sockets, you're going to add, about $10 extra of cost to that bill of materials, depending on what your cost per bulk of those sockets are. If you want to just throw the chips in there and solder the chips in there, you save that cost. So it depends on how you want to do it. Personally, when I send these out, I like to do projects with sockets to make it to where somebody wants to repair, replace, upgrade, do something later, they can just pull out a bad chip, put a new chip in, and they don't have to go through the old unsoldering thing. But there's schools of thought on that, whether solder's better or whether sockets are better or this or that or the other.
And how do you decide if breadboarding makes sense or not? Like you decided to build the board instead of doing it on breadboard first?
Oh gosh, that's going to be. I would say that's going to be based on your skill set and the complexity of the circuit. Building this thing on breadboards.
Yeah, there's
I
hundreds of
wouldn't.
pieces there. That's not
Yeah.
fun.
If you
No,
were a breadboard
no.
champ like Ben Eater and you had everything
Oh,
all
Ben would
set
do
up
it.
and ready to roll, that might be like where you would start with this project. Start
Right.
on the breadboard, get everything all laid out, know everything you need to know. If you're like me and don't know a lot about breadboards or reverse engineering like this, I'd probably go straight to the reverse engineering.
Yeah.
What I'm struck by is the time delay involved without the breadboard. I mean, there's time involved with the breadboard, but you can't build this just sitting in your basement at home. You have to wait a couple weeks to get the boards from somebody. It's awesome that we have that service now.
Yes.
You could.
I should
but
ask
you
it
don't
as a
want
question.
to.
What do you
You gotta
mean,
pay for
Joe?
shipping.
Mhm.
Yeah.
I use not to do any sponsors because I know that there are some PCB makers who have been trying to court me and my channel, but I tend to use JLC PCB because they're relatively inexpensive and they're PDQ. You're not paying extra money for super fast shipping, but I can order boards and have them here from China in a week.
Yeah.
So it's not that bad, and especially when you're reverse engineering it in this particular manner, the board works. So you're not worried about trying to spin iteration after iteration after iteration. You're going to be like, do maybe one or two. You'll do one and be, oh, I missed a trace, and do another one, and then you're done. Right.
You're reminding me of the one of the few advantages of our age is when I was 16 and 18 and working on breadboards, I'd stay up the whole night and build it. Now I'm like, yay, I got a week. I can sleep nights.
Yes.
So there is a way to do some local prototyping with your laser printer and get all the etching and stuff that you need for the boards. I'm not saying that it's easier or harder, but that exists.
And for smaller boards, that can work. There are even some new 3D printer / CNC machines where you can put those copper coated boards in the machine, send it one of these Gerber files, and it will actually drill away the copper where it's not needed, and you can prototype them that way. Doing 2-layer boards with any of the 3D printer UV lithography type ways is a little bit harder. It's not impossible, but it is a little bit more complex because you're trying to line up both a top and a bottom together and selectively etching one side. If you want to do that, you can. And if you want to experiment with that, you can do that. And then you're going to be waiting even less time for your prototypes. And then you're also spinning a single board and not having to buy minimums of $5 plus $20 in shipping to get it here plus waiting. But it can be more difficult that way. I found in my personal experience that doing that lithography stuff, that home lithography, makes more sense for single-sided, really small projects. But again, that's just my experience. I'm not the boss of you. I'm not your mom. You can do whatever you want.
Speaking of mom, happy Mother's Day.
Yes, happy Mom's Day. Yay.
Here's a CPM card.
Yeah. So you talked about, rapid prototyping and getting these things turned around in a week and all that jazz. And I would be, we talked about this a little bit before the stream. I would be a little afraid of that 8-bit connector at the bottom is, half a millimeter off. And in the Apple, it's not that big of a deal, but in a PC where it screws to the case.
Yes.
Or it's Visa card.
Yeah, Visa local bus card. Yeah, don't reverse engineer those. You'll be spending hours and hours and hours of your life trying to figure out what the problem was when it really was just the Visa local bus sucks. But anyway, and that is a thing. So the cool thing about this is once you've designed this board, and I don't have it printed out here, you can just print this out. So let me see if I can do that. Print. So you can just print it out, and then you can you can cut it and lay it over top of your original board and see if how close the alignment is. And if it's off by any, you can adjust it, nudge it, and whatever. There's another project that I can't tell you about that I am working on, though, that I've done that for. And I spun some boards. The boards came in yesterday. I lined it up with the original board, and I only had like one little thing that was off. Just from scanning it into a scanner, throwing it in this program and doing it, I was able to get it within tenths of a millimeter. So it's all about having the right tools to do that. So Petter is saying the 3D board makers are slick, just relatively slow. The via drilling process was fun to watch drilling it back when he was with research and development for NTT. Yes. Again, this is Petter's board. Hey, Petter, how you doing? Yeah, Petter has a long and storied history with multiple different technology companies, so he is a super cool guy. Rudy's saying I've made dual-sided boards back in the earlys with 1990s with a plotter and specialized pens. Yeah. So that's kind of a thing that's coming around now. Again, is using that super inexpensive 3D printer technology, that X, Y, Z coordinate thing to be able to do these boards now for rapid prototyping. But no, I wouldn't suggest doing something this complex on breadboards first. Breadboards are for when I would say when you're designing your own circuits to start and then getting to the second phase of spinning boards would be the route I would take on that.
So Joe, then where are you with this? Like how far along in the process have you taken us so far?
So I'm about 50% through this process. I've already completed this entire process for a completely different board, so I know what the next steps are. So personally, I've done one of these using this exact same process from beginning to end. I just can't show you that one because I'm technically under an NDA. It's a project for somebody I'm doing for something. But basically, the next step after you've scanned it in, you send it off a 3D printing house, you get it in, you order in your parts, and you just slam the thing together. You solder it together, you stick it in the machine and see if it works. And if you did it right, it works. If you didn't do it right, it won't work. If you really, really didn't do it right, you'll get magic smoke.
And you break your machine.
Yeah. Well, the Apple III is already broken, so I'm not worried about that.
In general or just yours?
Oh, just in general. They're not. They're generally known to be unreliable. Yeah. There's the whole drop 3 inches that we talk about in the Apple III community because there was literally a service bulletin for the first run of Apple IIIs. They used some nascent techniques for building those in the early days, and they overheated really, really easily. So the chips would wiggle their ways out of the socket. So the service bulletin said, if you're having problems with your Apple III, lift the front edge 3 inches and drop it to reset the chips in the board. Yeah, they're just notoriously unreliable.
Scary stuff.
But yeah. So that's basically the process. It's a factor of finding your target, depopulating and scanning the board, getting into a program like this here, tracing it out, sending your Gerber files out to your 3D printer of choice, or not your 3D printer, your PCB printer of choice, getting it back, double checking it visually, make sure it's good, solder it together, throw it in the machine, see what happens. The upside is these chips are so jelly bean and also so fragile at the same time. If you fry it, it's not like you're gonna, who cares? You throw another chip in it, it's like whatever. And the process is so relatively inexpensive that cost is going to be a concern, but it's not like, oh my gosh, it's going to cost me $1,000 to no, the whole cost to reverse engineer one of these is probably like $100. And then once you've done it, then you sell them and you calculate your engineering costs accordingly over the number you think you're going to sell, and that's it. If you're doing them one-off for yourself, cost isn't a factor, right? I want to make my own copy of this just for me. Well, do whatever you want. It's a hobby, right? But when you're doing it for resale, to putting back into the community, that's where that calculation comes in, and then it's just math. If you have a business degree or have sold things, you're going to know how to math that out. It's I calculate this divided by that times this, and then that's the way it is. So,
Joe, I had another couple of questions that I want to ask about the process in terms of like the legality and stuff. But I was wondering, but I was going to ask you guys instead. Would you mind if is this a good time to spin through my project, because then we could use them both as comparison or contrast?
Sure, I'd love that.
Okay. So the thing that I wanted to share with you guys in the audience is when Joe suggested he wanted to do this about reverse engineering, I wanted to learn from him about how to do it. And this was maybe 3 or 4 weeks ago. And about a week or two after that, I fell into a project in the community with someone else. And so it was a neat experience so far. And Frank's 3D Shop, who's on the chat, he's the person I was doing it with. So what if you could go back into the same frame that you had with me, I'll show you a couple of, I'll show you how the story developed.
Mm-hmm.
So what I was working on in Marcintosh, I was working on the Amiga, and using it as a Mac emulator. And here, this is the back of my Amiga. So if you've not had an Amiga 2000, it's basically got the size of a big PC. And so that's a typical size PC fan there. And right there, you see that gray box underneath called Amax. That's called the Amax Cartridge. And what that is a device that plugs onto the external floppy disk drive port that allows you to install Macintosh ROMs in that cartridge, and your Amiga has access to the Apple code in the Mac Plus ROMs. It also gives a DB19, which you see a ribbon cable connected to, that goes to a Mac Classic floppy drive. And that particular ribbon cable is connected to the floppy EMU. This is a floppy EMU in a customized case, different than the acrylic case that Big Mess of Wires sells. And this beautiful gold case, my coworker printed this for me. So the first lesson I want to say, or a possibility, is if you want to get into 3D printing, find somebody that has a sexy 3D printer and wants to impress you, because they'll make something for you. And then I went to Thingiverse and I found Frank's awesome design for this case. So I found the case and showed it to my coworker, and he said, "I'll print that." So that's how I got introduced to Frank. And I couldn't find the size for the screws in the kit, so I emailed him, and we got to chatting and said, "Oh," he's like, "I'd really like to do some electronics projects." And I go, "Frank, do you have an Amiga?" And he goes, "Yeah, I do." So what it came about is, the floppy EMU then, so that's Frank. These are Frank's channels. The 3D Shop one is the one where I came across it, and the Playground one is the one where he does other projects that he just started up, and that's where we're doing some of the Amiga stuff. So going on from that, this is what that gray cartridge looks like inside. So now we're the two projects are, now I'm catching up with like where Joe is, right? I've got the device, it works. I've owned this piece of equipment since 1989. And in Marcintosh, people said to me, "Dave, I've never seen that emulator before." Because you can imagine there's all these other Amiga emulators that came about in years later, not, since 1990, and those were the ones people used. So this cool one that came out, one of the first two Macintosh emulators for the Amiga, it had this piece of hardware which makes it really unique, because you can connect real Apple Macintosh hardware to the Amiga and run just like your Mac Plus. So basically, instead of scanning it on the scanner, I took photos of it, and Frank and I looked at it and said, "Okay, well, let's start designing a new version of that." Now, this one doesn't look quite as hand designed. It's got these square corners and stuff, but it's very simple. So to take Joe's advice, start with something simple that you can get your head around. It's only got 474 logic chips, and it's got those two Macintosh ROMs there. So we started looking around and started designing this, and Frank used some tools similar to what Joe showed you to start designing a new version of this. Just to give you an idea and some of the contrast with what Joe showed, on the left side here, you're seeing a DB23 that connects to the back of the Amiga. So one of the differences that I learned is, in the case, a DB23 is not a common connector, no, but the Amiga uses them in spades. So just between the two, the DB23 female on one end and the DB23 male on the other end, that goes into the chain to the next drive, that's like $4 to $10, or I'm sorry, $8 to $10 right there. Because those things cost, if you're buying less than 50 of them, they cost like $4 a piece. There's good suppliers for them, but it's a significant cost. So we're working on this and really confident. Of course, we can reproduce this. It's pretty simple. It's just got a couple connectors. Well, then I started looking around in the community, and I found this diagram from the early 90s. This gentleman, Bjarne Rasmussen, had found some some design for a copycat version of this board without the ROMs. So it's simpler. It just has two 74 logic chips. But basically, we found a bitmap image that was kind of like what we wanted to build, but it's 30 years old. And instead of having the real one in our hand to test with, we're like, it wouldn't really be there if this didn't work. The person saying, "I even made these new diagrams, it seems to work." So we basically found an alternative to the Amax cartridge that's simpler. And then moved on to Frank designed this, our original PCB, where we're just like, "Oh, look how small we can make this." There can be a DB23 to the Amiga on the left side, a DB23 passing through to an Unreal Amiga floppy drive on the other side. This J2 is the DB19 that goes to a Mac drive. Hey, maybe we can invite the community to basically revive this awesome old emulator by building this thing. So what Frank designed is, he got the layout and he's got the things on order. So basically we're waiting for the first version of the board to come through. But basically we made some design decisions. We said, well, how could this be better than the old thing that we had before? Now remember, the thing I had there before, it was this ginormous cartridge sticking out of the back of the Amiga, and it needed 8 inches behind the computer and all the stuff. We're like, let's make it tiny. And then these DB connectors are expensive. So I'm like, can we put a JTAG on there, like the 20-pin JTAG that's on the floppy EMU that's really in the real Mac? And then the end user can decide if they want to buy the DB19. Because if you're just going to use a floppy EMU with this, you can just go JTAG to JTAG and skip, that extra $5 a cost or whatever. So that's sort of where we are with it. And it was super fun. Like for about 2 weeks, Frank and I talked all the time in email. He did designs. I double checked his work for like where some of the connections were, but he was the expert that seems to know a lot of the stuff that Joe knows about how to use the software to do these things. So that's sort of where we are with it. And what we did agree on, we agreed on pretty much everything we were talking about. But what we agreed on is we're going to make this an open source project. So, if somebody wants to, build it, let me turn myself off. Let's see. There we go.
Oh no!
Did you ever turn yourself off, gentlemen? Anyway, but that's where we are with it, and we're going to have a card to test in a week or two. And
Cool.
I joked with Frank, if you saw that image that I put up there, there's one. We have got one typo in it says Dr. Dave diversions instead of Dr. Dave's. I'm like, I hope that's the only mistake we have on it. But it's been super fun. And then, we have complementary skills, right? And can run the ideas by each other. So the other thing that's different than Joe's project is, you have the other person meddling in there, but Frank's been really generous about saying, well, it was your idea. I just want to do the thing. And we talk about how would it best work. Sure. It has some neat differences, right? It's an external device, so it doesn't only fit the Amiga 2000. It can fit any Amiga because they all share that port. But there's the added cost. We're not sticking it in the slot inside, so now you have to buy a $5 connector to make it go outside. But we're trying to make those things optional, and that's sort of where we are with it.
That is some excellent work. And I think that touches on a great point as well. As, when you're doing these projects, you don't necessarily have to do a one-to-one copy as you're working. And in your case, Dave, having that extra feedback helped you come to the conclusion of, yeah, we can make this actually a much better thing. And it's compatible with the old way of doing it, but it is smaller, better, faster. We can rebuild it. We have the technology.
So one of the things we got to do is think of how could we increase the potential user base for it. So one of the things was make it work on any Amiga. But then we said, well, you don't need the ROMs in there because it's 30 years later and you can download the ROMs from the internet and load them through software. So those things went away. Then we're like, make it more convenient there. But then I said, well, what if the person doesn't want to emulate a Mac Plus? That's a weird thing to want to do. What if they just have an Amiga and they want to use the floppy EMU on it? So we went out and found there's a third-party driver, so I can mount the HFS on it. So I run awesome. With the floppy EMU under Amiga OS 2.1. It just works. It's super fun to use. So instead of having a GoTech, I use the floppy EMU, and when I go over to run the Mac, the same external solid-state device works.
That is awesome. And that kind of touches on about having or not having the ROMs, kind of touches on the legality question. Also having, whether you're doing a direct copy or in your case, you're doing a modification of the circuit, touches on that legality question. And I think that in your case, Dave, you've killed both birds simultaneously because you're not including the ROMs, which Apple apparently still goes after people for 30-year-old ROM images. I don't know why. And then you're also, because you've made a derivative work based on actual reverse engineering techniques, you're not going to be worried about whoever that original company is and whether they exist and whether they're going to come, patent hound you about it or whatever. That's one of my concerns with this board here is that it's basically a one-to-one copy. I don't think anybody's going to come after me. I don't think Microsoft actually cares. There's no real proprietary code on it, so it's not like I'm copying anybody's IP in that particular case. Add in the fact that, you know, back in the day there were clones of these types of things left and right, and nobody did anything about it back then either. So I'm personally not too worried about it. But if you're going to clone or reverse engineer something a little bit newer that still has a potential original product market, you definitely need to be very, very careful. You're treading on rice paper there, because, you know, they own the technology, the man hours, the research, all of it that went into designing that original product. If you're just stealing it wholesale, borrowing it wholesale, whatever you want to do, yeah, they have every right to go after you for that. So it's a very important thing to.
And so, Joe, did you decide? So, did you decide what's the right thing for you for what you build? Does it become something that's on GitHub? Do you run it as a product you're selling?
Well, for me, I have a very unpopular approach to that, and it is a hybrid between a proprietary approach and an open source approach. For example, my Apple III encoder chips, right now they're closed source because I spent a buttload of time reverse engineering the Apple III keyboard encoder to make that work. Nobody's reverse engineered the AY5 3600 Pro chip before. I did that work. I want to ensure that I receive my due, for lack of a better way to put it, for doing that. But eventually, at some point, I will open source that code and the design. It's not like in that case the PCB is that complex or anything like that. It's not, whatever. This here, I will probably, when I release it, I'll probably be selling them, but also just on my website, I'll have Gerbers people can download and burn their own thing. Because in this case, it's not my design. I'm making a copy so that people can have a version of this for their Apple III if they're having problems finding original. And that's kind of the focus here. You know, so that, I mean, you know, if you're, yeah, I think that's a good balance there. It just really depends on what you're doing. I mean, each person's going to have their own way of wanting to do it. There are plenty of projects out there for these retro computers that are simple enough that people aren't worried about it. They open source it. They're like, go ahead and build it yourself, but I'm going to sell my own copy, whatever. But there are other ones that are just completely closed, and it just, you know, it's a personal preference, and those personal preferences tie into the market and how and whether or not they want to pay for it or not. So I tend to find the projects that are closed source tend to cost more, interestingly.
So maybe Matt and Steve, do you have a project? I know, Matt, you played with so many different toys, the modern ones. Do you have experiences with whether it was good or bad, whether it's cost-wise or efficacy-wise as the end user for those different approaches?
Well, most of the stuff that I've been using lately, they've reduced, if it's a modern product that replicates the functionality of something old, it's not a one-to-one copy like what Joe is doing. They've reduced the complexity of the circuit. They've moved it all into the space of an Arduino or an FPGA. So it's a single chip solution where the single chip has more power than the machine you're attaching it to now. But those things cost $1 or $2, right? Like, the ESP866 or 8266 that powers most of those Wi-Fi devices now, those are like $2 or $3 retail, and those have more power than any of the machines you're attaching them to. So the cost, you know, you'll be paying $30, $40, $50 for the device, but you know the cost is only $2 or $3 to make the thing. So it's a decision you have to make, right? It's a super convenient thing to have, but yeah, there is the proprietariness to it.
And I think that a good point on that is that you're skirting around maybe the question is that if, sure, the parts only cost $2 or $3, and if you're a high-end tinkerer, you know how to solder, you know how to program these things. If you want to buy those pieces and parts yourself and build it, you know, it's only going to cost you $2 in a few hours on a weekend. But if it's an open source project, but the pre-made thing costs $30, you know it doesn't actually cost that. You are paying for their labor to build it for you, to send it to you, so you don't have to. So there's that number that's in there. Yeah.
Yeah. In some cases, if you want, like you said, to gain experience as a new retro enthusiast, you want to buy the kit and build it yourself. when you factor in the time, you're not saving money, but you're doing it for fun. So do it for fun, do it to learn, gain that experience. That's a good way to go. And in a lot of cases but then you get into things that are just built on modern technology, and you can't solder this stuff. Some of it you can, but some of it is way too small surface mount stuff that's just, you're not equipped to work on that.
Depends on what kind of pain you're looking for.
Yeah. I'm not equipped to
reflow ovens and all of that stuff. And yeah.
Yeah. Getting there, but not yet. So
do all of you guys use SCSI to SD, or have you used it?
Yes.
Yep.
The reason I'm mentioning that one is because I think it's super interesting, the spectrum that product has gone across, right? You can still buy the 5.0 board made by anybody from the open design. And I used the 6.0 one because I wanted the features. And also, even though I don't know the people, I wanted to reward them by paying them $100 plus. I thought that thing was worth compared to the first revision. But it's super neat that we can all in the retro community plug ourselves into the one that matches for us. Because I'm working with a buddy who he's like, I'm using the 5.0, and I'm like, why are you using the 5.0? How long are you going to live? But that's the right decision for him, and for me, it was the new one that had a little more features and was closed development wise.
And to some extent, that's the benefit of the open source feature of that product is that that allowed people to take it, iterate on it. It's still SCSI to SD. It still uses a variant of that same setup software. It's familiar to everybody, but the 6 is so much faster and so much more reliable than the 5 is. Yeah, it gives you a lot of capabilities there. So silence. Nobody's talking.
Not awkward.
So yeah. And I in my case, I think that's one thing that I want to do with some of more, my projects that aren't so niche is, I would love to be able to open source them at some point and give that back to the community after I've, recouped my development cost, so to speak. So.
Well, you'd also be surprised, and again, I'm right there with you. I'm not telling you what to do one way or the other, but you'd be surprised if you put it out as open source, and I don't know why I air quoted that, but I did, and you put it up on Tindy as a product that you're selling that is the compilation of putting that stuff on the chip and putting the kit together and sending out the circuit board, people will go do the Tindy thing. You might have 3 people that go the open source route and do it themselves, but most people will just buy it from you. I mean, to get the chips, to get the EEPROM programmer, to get the soldering station, to get all the components in place, or $30 for a completed board, as Chris is saying in the chat.
Sure.
You might still wind up recouping your costs either way. And I've done that a lot. I used to do a lot of training and like teaching people how to do something, and the biggest benefit of teaching them how to do it in the training class was that they would hire me to do the job for them. You are the expert. Just take this pain off my hands. They sit through a 4-hour training and they're like, this is harder than I thought it was. And some people are like, oh, that's easy. I can do that. So, I mean, everything's there.
Sure.
Every end of that spectrum.
I guess then the next question is, since I'm learning this as I go, what are the thoughts on the way I should open source my projects? I already have a website where I'm selling them right now. I can easily just dump the source and the Gerbers right on there. But is GitHub kind of the place people use for that? I've looked at Git a couple times and stared at it agawk and then ran away afraid. So, and I don't develop my code in any normal process because I'm not a programmer. I just kind of slap things at a compiler until it works. So I'm not sure, if that makes sense in my case.
Well, 2 thoughts there. Oh, go ahead, Steve.
I was going to say, it makes sense. I use GitHub a lot. And since you're reverse engineering a Microsoft product, putting it on a Microsoft distribution network seems to be a match made in heaven.
Yeah, GitHub seems to be the place where almost all the projects I've been looking at lately are stored on. It seems to be the de facto canonical source for most of this stuff. It has a pretty easy to use interface, and it displays your README Markdown file right up there for everybody to see. That's my first thought. The second thought is it depends if you open source it, what you think the demand still is for the product. Because, for example, someone created the SD2 IAC for the Commodore 8-bits, and they open sourced it instead of making the product. And now you've got 30 different manufacturers or people selling them for retail price, whereas the original developer isn't gaining anything from that, So it really depends.
That's going to happen too. Yeah, that's just the world we live in, unfortunately.
But was that something? I mean, it was first off, it was something they chose, and like one of the other reasons I got to know Frank is there's a tip jar on Thingiverse, and I said, man, I have this sexy gold case for that thing. I want to give him something, and so that even started the correspondence. So there are ways to give people things both on YouTube channels and others if even if they decided they didn't need it for their invention.
Yeah, I try to. I mean, a lot of people have a tip jar or a PayPal for donating, and I definitely try to, because people who make, for example, the Pi 1541, again, open source, they don't sell it, but other people do, and they don't get anything for it. So donate to the creator, even if you buy it from someone else.
The other funny thing that I just want to remind you is I found this project that we are mimicking on AmiNet. Like the one thing you can go, well, maybe you put it on GitHub, but maybe you also put it on the Internet Archive, or you maybe put it on, you put it in Macintosh Garden if it's about Macs or something, because some of these things will survive decades and some won't. And what I love is we're reverse engineering a reverse engineered product already, right? I mean that's a pretty neat continuity. I'd love to, if this guy Bjorn Rasmussen, if anyone knows who it is, I mean, he has a contact information there from like 1992 or something like that. It would be awesome to let him know that there's going to be a new spin up of that.
The fourth new owners of his house will be happy to receive a postcard from you.
Exactly. Exactly.
Yeah. I think those are all really good points. And it's inspiring me now to add a tip jar to my website.
You've got PayPal, you just create the link.
Yep. Looking at other notes of things we potentially wanted to discuss. Steve, I think you were asking before we got in the stream here, what to be or not to be, when should you have or not have a case for an open electronics project? Was a question that you had posed in our pre-stream meeting.
Was that me?
That was you, man.
Should you? Oh, okay, sure, yeah. So I've got a couple of things that are just kind of sitting open-ended here, and I just picked up another open-ended thing that doesn't have. Well, I guess it kind of does have a case by the standards of the day that it was made. It's a tube-based audio amplifier, and the case is the little tiny part that holds the tube sockets, and then everything is above that, and the thing weighs like 15 pounds. And I'm hoping. I mean, we've been discussing it in a Discord, and I think it's a we think it's a tube-based amplifier. So I don't know. I mean, basically, my thoughts on that are, anytime that there might be a situation where you can accidentally ground something or strange voltages coming in contact with things that you don't want them to come in contact with, that'd probably be a good idea.
Joe, you reminded me, now that I understood, I reparsed the sentence. When you said make a case for, I thought you meant in the vernacular, make a case for something. You literally mean make a case.
A chassis.
And if you remember, like this is the back of my Amiga right now, and it kind of scares me, right? The Amax cartridge, and we intend this device to have a case, but then look down the ports there, that video card is just open and anything can fall on it. The thing that I would encourage is talk to someone like Frank or somebody who does 3D printing and say, what would work well here? Because the other thing is, we're expecting this device to be able to be chained. So you'll have more than one of them there and have 2 Mac drives available to you. If you do that, it needs legs, right? It has to be supported. And so we're playing around with ideas about, one of my ideas is, can we use the mounting screws that you put together the case with to be the legs? And not have any additional cost, and then just put thread protectors on, and you have got rubber feet on it then, because that's what I did with some of my projects. But yeah, I think that's pretty interesting, and there's a different talent set, and it's another good place to collaborate because because
there is such a thing as too small. So this is a C64 dead test cartridge, and it's so small that I can't even get it out of the machine most of the time.
You gotta reach in. Yeah, I have the same.
Nothing to grab onto.
Yeah,
and so it doesn't have the hole, so I can't put it into a 3D printed case.
You need a Versa 64 card. I know a guy who has 14 extra PCBs just kicking around. They can be mounted in a case.
I'll have to talk to that guy.
Yeah, see if you can find them sometime. He knows how to 3D print cases for him now too.
Excellent.
Hey, Matt, did you ask in the chat if you can retrofit your Classic 2 to an SD30? Was that you?
Yeah, well, we were talking about an SD30 replacement board just a while back, and I did ask that question.
Is the new Logic board? Is the new Logic board? Does it fit in a?
The Classic, yeah, I don't think the Classic 2 and the SE30 are similar enough for that to work. They have. If anybody in the chat happens to know, Petter might know because he knows a lot about those things. I don't. The Classic 2 uses that same front edge connector that the Classic Color Classic does, but I could be wrong. And if that's the case, they get all of their video signals and everything in a completely different way from the way the SE30 board does. So I'm not 100% sure on that, but probably not. Darn.
Well, I don't know if it's really broken yet anyway. I haven't dug into it because I've been acquiring more broken machines on top of that. So.
Yeah, I saw those pictures. That was some carnage.
Yeah, I'm surprised how that happened, except I'm not sure if it shipped that way or if they just weren't properly screwed down to start with and they came out in stripping. So
I was being obtuse to let you talk about what it actually is if you want to. But we can continue this completely obtuse, arcane.
Oh, yes. No, of course. I'm sorry. Context is important, right?
Yes.
Matt, you're not under NDA.
Yes, no.
Maybe you are. I don't know.
Yeah, I acquired a $75 Tandy 1000 that came complete with the full DMA RAM card, hard card, and it was shipped very well packaged, completely wrapped, nice box, bubble wrap, this thick, perfect. But all the stuff inside was not secured, so they came loose, started jiggling around, started knocking chips out, started damaging the ISO slots.
Man.
So, yeah, it's a project now. I've got to replace at least one slot, replace one chip, and we'll see if it works after that.
And the card he's talking about is the one that's got the 3.5-inch Western Digital chonky
hard drive on it. Bouncing around in the machine, knocking stuff. Yeah, hard card.
Damaged the ISA slots.
Yeah.
Man.
It screwed them all up. They're all, torn up now. So
sheesh.
That's going to be fun to desolder. Do it with solder braid. I want to see you cry.
No. I have a brand new desoldering station I haven't even got to use on the channel yet. So
which one did you get?
I ended up getting the Heiko.
Oh, okay.
Yeah.
Good. Yeah. They require a lot of maintenance. You got to keep them clean constantly. They clog very easily. I found that out
I feel like
hard way.
I feel like I'm the only person that cleans the desoldering gun in a video. Like nobody else I've ever seen clean it while they've been
saw
working.
you. Yeah, and you were doing it at high speed. It was a fast forward, but I saw you sticking the cleaning.
Like, why does nobody clean this thing? Is mine like the only one that jams all the time?
You're the only one who records it.
Yours is the only honest channel.
Yeah, I try to be
We're all
honest.
liars.
I make lots of mistakes. Some of them I keep on camera.
But repairing boards is kind of tangential to the reverse engineering. If you want to get into repairing boards, reverse engineering an existing PCB like this is a kind of a good entry point because you're going to learn a lot of little techniques of desoldering and fixing traces and doing that stuff before getting into an actual busted board that you want to get repaired and up and running. So, yeah, I think that's pretty neat. But repairing board traces and stuff is its own kind of magic secondary type of thing. Yeah.
I'm hoping that hard drive was parked, Matt. I want to see it. I want to see it spin to life.
Yeah, what brand was it? It's one that they don't make anymore.
It's like a knockoff Western Digital, I thought.
Yeah, I've heard of it before. Oh, let me take a quick look.
Eastern Digital.
My photo gallery here.
Far Eastern Digital. Yeah.
Oh yeah, it's a mini scribe. That's what it is.
Oh yeah, I've heard of them.
Oh, okay, okay.
So like this one, go ahead. I'll wait for you.
Oh no, it's just a half height mini scribe, 3.5-inch drive bolted to the card. Yeah.
So it's twice the height of this one. This is the Plus Hard Card 20, and in order to get this one to come to life, you literally whack it on the desk.
Mm-hmm.
And it's something about they call it stiction.
Mm-hmm.
So like you have to get stuff moving again. You can power it up, and I've actually made a full backup copy of the data that's on here after whacking it a couple of times to get it to come to life. Mm-hmm. But I was like, I have nothing to lose. It already doesn't work, so unscrew it, thunk, and I
Yep.
did it on camera.
Yep, the either the heads will actually kind of stick to the surface of the platter, or the platter motor won't. It'll get stuck in place.
I think it's the thing that moves the heads out,
Mhm.
so that the heads work and the platters spin, but until you can overcome
The voice
that,
coil. Yeah, well,
yeah,
the voice coil bearing, and depending on some of those, if they're sufficiently old enough, they're not as susceptible to failure due to hermetic seal opening. So in some
Yes.
cases, you can actually just open them up, and with it spinning, you just kind of tap the head, and it goes, and it'll do the thing.
yeah. I've opened up some of the old ST225s and put them back together. They work
Mhm.
fine.
Yep.
The tolerances aren't as tight as they are on modern drives.
Mm-mm, mm-mm, mm-mm.
So you have nothing to lose, Matt. Go for it.
Yeah. Well, let me get the ISA slot fixed and source some new parts, and it'll be a fun project. It needs the works. It's going to be torn down all the way to the base. There's some surface rust on the chassis that's got to get fixed. It needs full retro bright. But in the end of the day, hopefully I have a fully working $75 decked out Tandy 1000. So we'll see.
And being a Tandy 1000, that means it's only got like 3 ISA slots anyway, right?
It is the original. It's not the SX. It doesn't have 5. It's got the 3. Yeah.
But luckily,
So-
it's got built-in sound. So
Mm-hmm.
And so we're going to be seeing videos of all of this, right?
Yeah. It's going to be a long-term project, so it may be in time for Septandy. I have a Coco 3 project I want to do too, so I'm not sure which one to start first. That needs a lot of attention as well. But yep, we got Tandy projects in the works, so that's always a good thing.
it'll take you a long time to source those ISA slots.
I heard that they're available on AliExpress. I just haven't gone looking yet, but that's on my list of things to do.
I went looking a couple days ago, and I was shocked because I actually bought them in the place I bought them from Mauser, and I can't find them on Mauser anymore.
Oh,
It's also super hard to search for like a part when you don't know what it's called, or
Part of it too is just Mauser and DigiKey's search font features are kind of suboptimal. A lot of folks like to go to RS Components, either the Australia or the UK site, because I'm told that their search features are better. Once you find the part you're looking for, then you go to Mauser and order it. Speaking of Septandy, anybody planning on going to Tandy Assembly this year?
where is that?
That is the yearly, it's like Kansas Fest or VCF. It is the yearly Tandy get together in Springfield, Ohio.
That's not too far.
that's not too far. No,
They've of course they were off last year, but they're planning on having an actual in-person meeting again this year. So it's like a 2-hour drive for me, so it's not that big of a deal.
Yeah.
But
Well,
Hubris is asking what we're doing for Omega.
Omega,
oh, that's a good one. But wait, it's May. I haven't started anything for that.
I'm gonna watch lots of Amiga videos.
I have no plans.
Hmm.
Well, I was
Is that a
typing
real
it.
thing, or you just make that up on the spot?
It is a real thing. I was exhausted from Marcintosh, so I didn't
Yeah.
volunteer to promote it. But one of the things that I'm going to do is I'm learning Apple II, and I found a 30-year-old Apple II emulator that's quite nice, actually, for the Amiga. As long as you have an accelerated Amiga, it runs. And I ran David, 8-bit guy David's Attack of the Petsky Robots, the Apple II port. It runs on my machine. So
Awesome.
I'm going to show. So the challenge of not having ever used Apple II and going back to it, like even learning what's the difference between a ProDOS ordered and a DOS ordered disk, and that you can have a DOS ordered ProDOS disk. That's the thing that blew my mind. Ron from Ron's Computer Videos taught me that. So I managed to get that running on there. So that's one of the things I'll do. And then the other thing I'm going to do with the Amiga for this month is I can fit in how to use HFS. Actually, use Mac HFS as your bridge file system to get things to the Amiga. It works super nice because you can have a modern Mac and mount it up with HFS utils, drop things on the floppy EMU, and then read them directly on the Amiga. I think it's a non-obvious choice for a bridge file system, but it works really nice.
I think that would work really well on the Windows side too, using CiderPress, because you can do the same thing with HFS images using CiderPress as well.
Is CiderPress a commercial?
No, it's free.
It's free.
Oh, okay.
It's free.
Because that's what people suggested I use CiderPress. I found another Java-based alternative to Ciderpress, and that's what I was able to convert some of the files with. But pretty neat. Anyway,
Thomas Armstrong said DigiKey has those parts for $6. I think he's talking about the ISA cards.
Yeah, the ISA.
Thomas, if you have a link to that, drop it in the chat, and one of us might be able to public that link so we can get to it.
Yeah, thanks, Thomas. Appreciate that. That'll help a lot. I'll get that ordered right now. Well, I've got the attention of experts.
Yep,
I am
there's the part
also
number.
looking for a replacement battery for the BIOS chip on the Tandy 1000. It got knocked out and completely mangled, and I'm sure the battery's long since dead anyway. I don't know. There was an aftermarket third-party project that made a replacement, but they're no longer on the market. And I don't know if it's open sourced, but if anybody knows where those could be sourced, I'd love to hear it.
Tandy 1000. Do I have one of those?
So Chris is asking if it's a Dallas chip, and because you're asking, I would say it's not.
It is not.
Might have to. I have one of those Tandy 1000s back here. I might have to open up, take a look, and see what mine has in it. So
there's
It
a
might
lot
be
of different variations and permutations. This one is the original 1000 HD designation.
okay, so it doesn't have it like it's not an HX, a TX, an SX, any of that stuff.
Nope. No.
Okay.
The SX
Well,
is
then-
the one to have if you want the big box early one, and then the TX I think has the 286 processor perhaps, and then the HX and the EX are the reduced form factor, like wedge shaped ones, I believe. Smartwatch, yes, Chris, that is what it is. The smartwatch chip.
Okay. So it's the whole
Indeed.
chip that's so basically it's the whole chip that's the issue because it has the baked in epoxy in battery.
Yeah, it's all in a solid unit. Yeah.
You might, this is a total stretch. Have you looked at one of the no slot clocks that's compatible with the Apple II? Because there's some aftermarket versions of that are effectively as the same, they're all the same form factor. The same chip worked in Apple IIs. It also worked in IBM PCs. Because basically it just listened to the bus it was plugged into transparently for a specific byte sequence to come across the bus. And it would then take over the bus, spit data out, and then release it again. And it worked the same on a whole bunch of different systems.
Mm-hmm.
So that might work. I don't know.
Yeah, I'll have to do some research. I'm sure I'm not the first person to have this problem since those batteries die anyway. Mine just is dead and destroyed, so I can't.
First person problems.
Yeah.
Well, we're coming up on an hour and a half. I think that was what we wanted to do for our stream this evening. Did anybody else have anything else they wanted to bring up, chat about, talk about before we say goodnight for the evening?
Remember your mothers tomorrow.
Yes.
Give them a call, give them a visit. I spent 7 hours today cooking 4 meats on the smoker, so she's getting a big barbecue dinner.
Awesome.
Nice.
My mom took a vacation, so my job for her for Mother's Day is to go visit my dad to make sure he's not lonely. So.
All right. Well, we're having a Zoom dinner. That's our plan.
Ah.
I haven't seen my folks in a year and a half, but that's all about to change soon.
Cool.
Awesome.
That's because your folks are out of the country, right?
Well, they're up in Maine. My sister's out of the country. Yeah, and I can't see her. Canada's on lockdown, but yeah, they're just a far ways away.
Canada's on like report your neighbor lockdown.
Yeah,
that's crazy.
Yeah.
Mm-hmm.
And it's too bad because I've got a whole bunch of machines at my sister's house I would love to pick up and bring home one of these days, but it's been a year and a half or longer. So someday.
Good. Well, I think we had a super awesome chat this evening. I want to thank the three of you for stopping by to my channel. Maybe we can make this a more frequent thing under the 4 Geeks in a Podcast name. I thought that was kind of tongue in cheek and on the nose. Yeah, thanks for everybody who stopped by in the chat and dropped all their comments and everything. We appreciate that. And we will see everybody at some point in the future.
Thanks
Bye,
for tuning in,
everybody.
everyone.
Take care.
Thanks, guys. Bye.